So that's what was in that video, amongst other things. So I thought what we would do here is number 2, and we'd start off with number 2. And knowing you guys mostly as well as I know you, I know that you pretty much have the calculus stuff down, but sometimes it's the algebra stuff, which you feel like ought to be easy, sometimes is what trips you up. So I thought I'd get you off to hopefully a good start here, number 2. If I was going to be finding a derivative like this one asked me to find, what might I do before I did that? Say again? Do something with the negative 5 over x squared. Do what? Flip it up. Flip it up. How about h of x equals e to the negative 5 times x to the negative 2? Okay, so based on that, why don't you guys see if you can find h prime of x, then we'll move on to some other more interesting examples. All right. The way that I'm going to think about something like this is I'm going to think that the derivative of e to the something is just e to the something. So it's going to be e to the negative 5x to the negative 2. But as always, the chain rule factor is in there somewhere. Sometimes the chain rule factor is just a 1. That is not the case here. This would end up being positive 10 x to the negative 3rd for that chain rule factor. Just keep in mind that the chain rule factor is down there on the base level. It is not in the exponent level. I've tried to make that clear with how I've drawn that in there. So just be careful that if it's supposed to be an exponent, make it an exponent. If it's a base, make it a base. This one, the 10x to negative 3 is a base. Okay. Pretty basic example. We good? Okay, then let's take a look at number 3. Number 3 is a little bit less of a basic example. I would say number 3 is kind of an application of this without using a calculator, at least for the moment. See if we can find local extrema, local min, local max. Okay, so give it a shot. F of x equals x e to the x. I'll do a little check-in with you here in just a minute, make sure we're on the right track, and then we'll see how it goes. All right, number 3. So let me check in with you really quick. Nobody has to admit anything if you didn't do this, but did you all see the product rule?
Yes.
Okay. Sometimes that sneaks up on you. Happens. So why would I be doing the product rule? Because I'm looking for a derivative, right? Hey guys, could you quiet down, please? Thank you. So I'm looking for a derivative because I want to find my critical numbers. So I'm going to say f prime equals 1 d2 plus 2 d1 would just be a 1. And it's frozen. It's hard to see. So again, I'm looking for f prime because I want to find where f prime is 0 or doesn't exist because I'm looking for critical numbers because that is where I'm going to find my relative extrema, my local extrema. So take a quick look at that. I always check this. Is there any place, any x values that you can think of where that would not exist? I'm glad you're quiet because I think it'll exist for all x, all real x at least. And so the only thing I really need to concern myself with is where does that equal 0? So what might you do to get started on solving an equation like that? That's right. Factor out e to the x. So e to the x parentheses what?
X plus 1.
That's right. So then, according to the zero product property that y'all learn in like Algebra 1, Algebra 2, wouldn't you guys do this? One of those is simply not true. Which one is not true?
E to the x equals 0.
Yep, that is never true. E to the x never equals 0. Can you picture the graph of e to the x? And doesn't the x-axis function as like a horizontal asymptote? So yeah, e to the x never equals 0. But x plus 1 does. So our lone critical number is x equals negative 1. You have a choice here. What do you guys choose? Would you do a second derivative test to decide what this is, or a first derivative test? First makes a lot of sense. I think you're right. So let's see. I think we can do this whole thing without a calculator. So let's try that. F prime sign chart. What number would you test to the left?
-2.
-2. Okay, I like that. So f prime of negative 2 equals negative 2 e to the negative 2 plus e to the negative 2, which is negative 1 e to the negative 2. And what kind of a number is that? Definitely negative. So f prime is negative on that interval. So let's see what happens over here. What number would you plug in on the right?
0.
Yep, 0. What's the result if you plug in a 0? 0 plus 1, right? Because e to the 0 is 1, so you get 0 times 1 plus 1, so you just get 1. Of course, that's positive. So just looking at the sign chart, do I have a relative min, max, or neither? Relative min. So then we work on our justification over here. Anybody want to try it out? Like, what would you say if you were going to write out or say out a justification? Anybody want to try it? We're all just going to be quiet. I wasn't even trying. Oh, yes, Jasmine.
Because f prime of x equals 0 and x equals negative 1, and f prime of x changes from negative to positive, there is a relative min at x equals negative 1. Appreciate it.
I think I got it all up there. What do you guys think?
Yes.
Look at that justification. We're solid. 2 thumbs up. Jaden, question.
So, for the first derivative test, you plug it into f prime of x or f of x?
You're testing the first derivative.
Okay.
So you plug into f prime. Good question. And, of course, if you're doing the second derivative test, you plug whatever number into the second derivative. Absolutely. The only thing I see, does anybody see anything that could change about this? Jasmine, I think, has a really good justification. I think it's probably be super solid, full credit. There's just like one little tiny tweak maybe you could do. Okay, I would say this. And f prime changes from negative to positive at x equals negative 1 maybe? Something like that. You guys know the first derivative test completely hangs on continuity as a condition. And so I think you've got it there. You guys see how she could be a little more economic with this? What could she say instead of that would be a little quicker?
F of prime negative 1 equals 0.
There you go. Just say f prime negative 1 equals 0. I'm picking here. You did a really good job. I'm just trying to point out ways that it could be a little bit different, but I think you're fine. Please don't take it as me being critical. I'm really not. You don't look very hurt.
Personally offended.
You're offended for her.
Yeah,
Okay.
on her behalf.
Sorry.
Thank you, Liz.
Okay. True group efforts. All right. Any questions, comments? Again, Jasmine, thank you. I think that really was good. I really do. Anything? All right, let's move on. Of course, if you can differentiate stuff with e to the whatever, you can, of course, anti-differentiate it as well. So the antiderivative of e to the x dx, of course, is just e to the x plus c. And as long as Timmy has not messed up with his du, the antiderivative of e to the u du is simply e to the u plus c. But of course, if he's messed up the du, we might have to do some substituting to fix that, or a fix to fix that, right? Just either way that you choose. Okay, so let's do some examples here. I think there's 3 or 4 of these. Let's see what they look like. Yeah, so Josh alertly pointed out, no, that's on the next section, isn't it? These are actually fairly well directioned out. So 1, 2, 3, 4, I think you'll find some interesting things with all of them. I think they're all pretty well done. So please try 1, 2, 3, 4. We'll get to the definite integral after that. Ready, set, go. Again, you're going to find that, at least I find that looking at this as a Timmy messed up the chain rule process is going to be faster than going through the full U substitution. Here's an example, number 1. I'm going to look at the inside. I'm going to ask myself, what's the derivative of the inside? And it should be 3. Is the other factor of the integrand 3? No, it's just a 1. Timmy has messed this up, of course. So I'm going to fix that. I'm going to multiply the inside by 3. Now the chain rule pattern is perfectly fixed. To balance that out, I've got to multiply by 1/3 on the outside. Yes, sir?
What is this Timmy thing?
You didn't watch your video, did you? I think that was when he missed. Maybe. I don't remember.
Was it when I missed?
Deathly
I think so. You need to watch the video.
Oh,
It's
that
all
was
in there.
definitely-
Timmy's a fictional character that always messes up the chain rule, and we have to fix his issues. I don't know who that is, but okay.
Okay.
We'll go with that.
I missed the chain.
Check out that video. Yeah, it's back there in 4.5, I think.
Okay.
Yeah.
I
Yeah.
know, I've watched all the videos, maybe I just wasn't paying enough attention.
And I did both. I did a substitution and Timmy, but for these simple ones, I'm always just gonna like fix the factor.
Maybe you are in the
Jake,
back.
just don't let it happen again, okay?
What she said there. Okay.
Who's accepted now, Jake?
So the three just anti-differentiates back to the inside. The 1/3 doesn't go anywhere. The antiderivative of e to the u du is just e to the u. And listen, if you have any doubts, hey Dylan, if you have any doubts, what do you do? If you have any doubts as to whether this is the correct antiderivative, what would you do to check? I put you up because you kept on talking over me. You're like, I just wanted to be able to express, and yeah. So basic rule of propriety here is when you're talking, I won't. When I'm talking, you don't. Okay.
That rhymes too.
I'm on a roll. On a roll.
You should rename yourself Dr. Seuss.
Dr. Seuss, yeah. Only not nearly as clever, but whatever.
Again, clever whatever. Seriously.
I would say that I should play the lottery, but I don't know how this would affect the lottery. And that rhymed too. Okay, it was the same word, so I don't know if that counts or not, but whatever. With number 2, did you guys pull the 5 out? I think you got to do that to be able to see the pattern. Here we go. So funny. All right. So now, you look at this and you say, what's the derivative of the inside? Isn't the derivative of the inside negative 2x? And you look at that other factor and you say, is the other factor negative 2x? Of course not. You got to fix it, and we adjust for our fix. Did you all get negative 5/2 e to the negative x squared plus c? Okay. Any questions? Especially concerned, Jaden and Jeff, this is your first time through on this. Are you doing okay? Any questions? Ask, go.
All right, we're just curious why we need to keep correcting Timmy when we should just teach him how to stop messing up.
Is this the teach a man to give a man a fish, feed him for a day, or teach him how to fish and feed him for a lifetime?
You're gonna have this problem every day.
Well, if you could ever get Timmy in here, maybe we could help him.
Don't teach me.
I did, and I wasn't able to get through to him. I don't know. There was something there. I don't know. Okay, number 3. I'll just go quick with this. What's the only adjustment needed? A negative sign, right? The derivative of cosine is negative sign. So you end up with negative e to the cosine x plus c. And then the last one is definitely the trickiest. Once again, because there's some algebra, and algebra sometimes we think is easy, but it's not always quite like that. So number 4, let's see here. We got to do a little bit of manipulation. So I'm going to say, first thing I'm going to do is rewrite as integral or antiderivative of e to the x to the negative 1. And then that whole thing is times x to the negative 2. I'm just going to basically get rid of anything involving a fraction, convert it over to a negative exponent. And maybe I'll do u sub here. If I was going to set this up with u substitution, what would my u have to be? X to the negative 1. And then my du then would have to be?
Negative x, negative.
And don't forget dx. So then when you start substituting, you get the antiderivative of e to the u times x to the negative 2. What could I replace the dx with? That's right. And do you see how everything will cancel except for that extra negative hanging out there? So this, I just heard a what? Are you guys okay? Or okay, maybe I misheard. So those would cancel out, but that negative hanging out under the du would still be there. And so this would anti-differentiate to be negative e to the u plus c. Our final step would just be to get whatever the u actually is back in there. So it'd be negative e to the x to the negative 1 plus c. Okay. We good still? Okay. All right. So number 5 is absolutely positively no calculator because if the calculator was active, what would you do?
Plug it in.
And use Math 9, right? So I don't want to do that here. I want to see if you guys can evaluate number 5 without a calculator. So please do. Give that a shot. And same with number 6. I think that's it. Oh, there's 7 too. Let's just do 5 and 6 right now. Please do it without a... Because if you could use a calculator, wouldn't you just go Math 9? Make it as complicated as possible. Okay. I guess you could do that.
I mean, because that's right.
That's just who you are.
I make it my
Okay, here we go. Hopefully you guys have had enough time to handle this. You guys okay with an antiderivative of negative e to the negative x? Yes? And then evaluated from 0 to 1. You guys are all good with that notation, right? The vertical line. Excuse me. Wow, thank you. Just happened all of a sudden there. And then you plug in the 1, and then you plug in the 0. So I'm getting negative e to the negative 1 plus
1.
Don't fall to the temptation to think that's a 0. It's a 1, right? It's easy to think that. Okay, so without a calculator, that's about as far as we can go, right? Okay. And then number 6. Again, looks a little more complicated. But if you look a little more closely, I don't think I would do u sub here. I'm simply going to look at this and say, what's the derivative of the inside? And the derivative of the inside is just e to the x. And look, the other factor is e to the x. So this has been perfectly set up for the chain rule. U substitution would not generate any changes. And so I'm simply going to write down my antiderivative as sine of e to the x, and then evaluator from negative 1 to 0. Is that working? Okay, then we plug in and subtract. So it'd be sine of e to the 0 minus sine of e to the negative 1. So sine of 1 minus sine of 1 over e. I know for sure that we don't know what sine of 1 over e is, but is sine of 1 one of those unit circles? Yes. So unit circle angles? It feels like it should be, right?
But it's equals 1.
But it's like sine of whatever equals 1, not an input of 1. So sine of 1 is some decimal, whatever. So yeah, we'll just leave it as is. It's about as far as you could go with this one. Any questions? How are we doing? Okay, if you haven't already looked at number 7, please do look at number 7. And we'll wrap up our day here in a little bit. Number 7 is so lovely, isn't it? Although what?
It is what we're doing next.
It is what we're doing soon. Yes, sir. Absolutely. Okay, so what follows is a couple of basic rules here. And welcome. Sorry there was an awkward pause when you walked in. So these rules, this is one of the rare moments. This might be the only moment. Maybe we can think of a few others. One of the rare moments where basically the task is make sure you know these rules because you might possibly see 1 or 2 of them on some assessment later on, and you don't want to give up 1 point just because you didn't know the rule. We can always derive these derivatives and figure out where these rules actually come from, but it's probably best just to remember them. Hopefully you watch the video, or maybe you just remember these. d dx of a to the x is equal to what? No, because it's an exponential. The base is a number like 5 or 7 or 10, and the exponent is a variable. So it's the other way around from the power rule.
Oh, x a to the x. X times a.
No, it's definitely not this. We can't use the power rule for an exponential. It's just not true.
X times a to the x.
Oh, it involves an ln, yes.
Oh, the x. Oh.
ln of x. Oh, ln of a times.
It's that. So the way that I remember this one is that it still works for e. So if you think about it, if you made the a and e, wouldn't it be ln of e, which is just 1, times e to the x. So ln of a times a to the x. If you're dealing with the chain rule, it would be ln of a times a to the u times du dx, or u prime. Anybody remember number 2? Anybody know number 2?
1 over ln
Remember x on the
X ln of a. Yep. 1 over, and then the whole denominator is x times ln of a. So again, it's one of those things where if you're thinking, where's this going to show up on a test? Do I need to memorize these? Well, if you're willing just to give up a whole question and get no points on it, you don't really have to memorize these. But I would advise you to get the points where you can, because these are really straightforward if you know the rules. So this would be 1 over u ln of a times du dx.
So that's like the derivative of u then, right?
Yeah, what derivative of whatever u is.
U prime.
U prime. U prime would work too. Yep. Okay, and then finally, number 3, the antiderivative. Well, isn't the antiderivative just the opposite of the derivative? So if the derivative of a to the x is ln of a times a to the x, the antiderivative would be what? Instead of multiplying, you would end up dividing, right? So it'd be a to the x divided by ln of a, and then don't forget the always popular plus c. Okay, so like I said, these are just the types of rules. In my opinion, to be most efficient, you just want to memorize these things. You know, we could show the change of base formula and how to do number 2, and we could do a differential equation to show you number 1. In the end, you just got to know these. To me, that's the best way to go. Anyways, why don't you see if you can take these and apply these to the final questions of the day, which would be numbers 1 through 6, 5? No, 5. There we go. Wrapped up.
This is the one. This is the one.
Y equals 2 to the x. We're supposed to differentiate. Let's just run through these. I think you hopefully can apply quickly these rules. What do you guys think the derivative is?
ln of 2 times 2 to the x.
Okay, we solid? We good? You can just apply the rule. Like I said, this is a rare case where very little high-level reasoning needed. Just apply the rule. Okay. Number 2 obviously is a little more of a chain rule situation where it's going to make a difference. Ln of 2 times 2 to the 3x times 3. If you wanted to be super tricky, couldn't you write this as ln of 8 times 2 to the 3x? Oh, use a little log property, right?
No.
2 cubed is 8.
That's not.
That's not? Okay, fair enough. We'll just move right on past that one. Number 3. Y equals log base 4 of x. 1 over x times natural log of 4. Looks pretty good. Number 4, y prime equals what? Times?
Good job, Jasmine.
Jasmine's on this. Or couldn't you be very Jasmine-like and write this as negative tangent of x over natural log of 10? I think you could. Friday at 2:57. Too much. Too much. Okay. And finally, the last one here, number 5. Whoa. It's almost like Jake was waiting for that one. He did get the plus C in there. Okay. Hey, before we fully wrap this up, just a reminder that next week we have class on Monday, right? Yeah.
Yeah.
Navy is on a Monday.
Not Tuesday.
There's still 3 meetings next week, though.
Modified schedule.
Monday, Wednesday, Thursday.
I think it's Monday, Wednesday, Thursday.
Garbage.
Modified schedule next week, right?
We never have this class.
We have red and orange on one of those days.
What day do we have the test? Is it really the time?
Hold on.
Sorry.
This is what I wanted to talk to. Hey, guys. Hey. Hey, guys, will you quiet down, please? Listen up, please. Hey, I'm so sorry. I know I'm interrupting. I'd like to get you guys out of here on time. So we had our test scheduled for Wednesday, and I know there's some modified schedule stuff. I'm gonna have to look at the scheduling and see what all the timings of everything is. I'm gonna have to get back to you whether we're gonna do the test on Wednesday or Thursday. I don't know which it's gonna be at this point. So they changed. It's so funny. They ask us to be like It asks us to be like 2-3 weeks out on our scheduling, and then what do? They change the schedule. So it's like, okay, thank you very much. So we'll just adapt. I'll let you guys know. I just want to let you make you aware of that. Have a wonderful weekend. See ya.